Hey guys, this is the section 5.2 notes, but it's just for simplifying radicals. So got it subdivided into 3 parts. So um, this would be the first part. Alrighty, so I would hope that you remember doing factor trees in the past. So if we eyeball up here this first example, square root of 48, forget the x for a second. Square root of 48 does not come out even. And unless the direction says round, you don't get the round. And if you don't get the round, then that means factor trees. So I'm going to show you 2 different ways to do it. I'm going to show you the long way, which some people prefer because it's consistent with what they've done before. And I'm going to show you a little bit of a shortcut. And if you like the shortcut, feel free to use it. So over here, I'm going to come clear over here on the left where I got more room. So I want to do a factor tree for 48. Well, hey, anything, right? So if you come up with 6 and 8, great. If you came up with something different, it doesn't matter. It all ends up the same at the end. Okay, now I'm going to get to the x squared in a second, but just for now, I'm going to keep going on the 6, which obviously would be 2 and 3. And I'll keep going with the 8, which is 2 and 4. Let's switch the order on these. I'll show you why in a minute. So the 6 is a 3 and a 2. There's the first 2. I take the 4, and I split it up. And if you want to do the little branches, you're welcome to do that. Okay, now I'm going to go ahead and take care of the x squared now. So what does x squared mean? I mean, it means there's an x times another x. So even though it's a variable, it's still like doing a factor tree. So if there had been 7 x's, you could have listed out 7 x's, etc. So down here at the bottom, you can read that line to yourself. So hopefully you remember that the deal was when you got to the bottom of the factor tree that you wanted to circle some pairs. So I see a pair of 2's, I see another pair of 2's, and I see a pair of x's. So all we're going to do here is what we've done in the past, which is to say every time you get a circled pair, you write one of those guys on the outside of the square root. So there's that one. There's that one. There's that one. And I'm left with the square root of 3 that didn't have a pair. So I want to keep going. I want to clean this up. I don't want to leave that 2 times 2 out there in front. I'm just going to go ahead and make it a 4. And there we go. So we got 4x square root of 3. So that's a little tedious, but I mean, come on, let's be honest. We can get third graders to do factor trees. So really, it's not that big a deal. So let me show you a little bit of a shortcut. And the shortcut would be this. Somewhere along the way, someone had to have made you memorize or taught you to the point where you now know a bunch of square roots that come out even. So for instance, the square root of 25 comes out even, right? It's 5. The square root of 9 is 3, etc., etc. So if you're good at factor trees, you can pull this trick. If not, you can always do it this way that we just did it. So if I can find a factor tree that has a square root that comes out even, that's the largest square root that goes into 48, I'm going to get to the answer super fast. So 16 times 3 is 48 if you weren't aware of that. And you can always use a calculator to fiddle around and find this out. But here's why I'm saying this is a shortcut and why this is way easier. I could continue to do a factor tree for 16, but don't we know what the square root of 16 is? The square root of 16 is 4. Okay, now notice I didn't say square root of 4. It comes out, and the key word there is out. It comes out even. So if the square root of 16 comes out even, why would I bother doing a factor tree for it? Okay, now we did actually talk about this shortcut with the variables. The root number for that guy is understood to be a 2. And if I just divide 2 into 2, it goes in there 1 time. And that's how I get the x. So we already had a shortcut for that. So feel free to use it if you want. And if not, if you like to circle the pair method better, then do it. Either way is good. All right, square root of negative 50. So I would challenge you to pause the video right here and type the square root of negative 50 on your calculator. I'm going to guess you didn't, but I'm going to tell you that it's going to give you an error. So in other words, it's impossible to do a negative square root. So how about this? What if we did a factor tree for negative 50 and we made it positive 50 times negative 1? Well, that's still negative 50, so technically that's a factor tree for negative 50. In the square root of 50, now it doesn't come out even, but your calculator is not going to give you an error. So in other words, it can do it. So I'm just going to treat the 50 like I normally would. Let's go ahead and do a factor tree for it. I got 25 and 2. Now you could shortcut right here. We wouldn't need to do a factor tree for 25, but I'll go ahead and do it the long way one more time. So I got a pair to circle. Where's the circle pair go? Inside or outside? It goes outside. And then I'm stuck with my square root of 2. Now I left a blank after the 5 on purpose, and this is going to sound silly, but it's a memory thing, and it's ridiculously easy as long as you just remember it. So if you put the square root of -1 in a calculator, it's going to say error, so it can't do it. So someone invented this little deal right here. It's called an imaginary number. So I know, make up your jokes, imaginary. You can imagine we did it right. You can imagine you got an A on the test, whatever you want to do. Come up with your own jokes. But what we're saying is we write the square root of -1, or any time you have a negative square root, as the letter I. It just stands for imaginary number. It's like sort of a little detour to be able to do a problem that's impossible technically to do in a calculator. So that's as simple as that. And my corny, lame joke is to say, every time you see a negative square root, you just pop an I out. So literally, every time we see a negative square root, we write the letter I, otherwise we treat it normally. All right, let's drop down here and do a couple multiplication and division problems. By the way, oh, no, okay, so that's it about the circling the pairs right there. So you are welcome to do it that way if you prefer that way. All right, well, guys, multiply is multiply. We're always allowed to multiply. So if I do 7 times 3, because they're both outside, I can get 21. Now, it's as simple as this. I see a negative square root right there, a negative sign inside a square root. And every time I see that, I write an I. And once I've done that, that's taken care of, and I don't have to worry about it anymore. I know it sounds dumb, but don't, there's this old saying, it says, don't look a gift horse in the mouth. So I'm giving you a gift here that's simple. Take advantage of it. Don't question it. Now, we could multiply the 10 and the 14 together. That's one option. And we get a square root of 140, but then you're going to have to do a factor tree. So how about this instead? Since we're going to have to do a factor tree eventually, why don't we just go ahead and do a factor tree now for each number? So I got my 10, 2 and 5, and I got my 14, which is 2 and 7. Now, just because the 2 in the first part came from the left half of the problem, and the 2 in the second part came from the 14, doesn't mean I can't count it as a pair. It's one whole problem. I'm supposed to get one whole answer. All right. I already had the 21. I already had to write an I because of the negative square root. Now I got a 2 on the outside because I got a circled pair. I can't factor tree the 5. I can't factor tree the 7, and there's no pairs. So we're essentially done. You just have to clean it up. There's no sense leaving 21 times 2 when I can do 21 times 2. I just got to write the I. And what would look better if I wrote a 5 and a 7, or if I actually times them together and made 35? So that would be a little more simplified answer. And that's it. Now, you might be looking at these division problems saying, oh my gosh, they're tougher. But you know what? For once, they're easier. What if I told you to do 120 divided by 30? I'm reasonably confident you would pick up a calculator and just do it. The only difference is they were square roots. So you get to do the same process or the same rules that apply. If it's a division problem, you divide them. The only difference was it was a square root. Now the question is, can you do a factor tree for the square root of 4? Better yet, does it come out even? And it does. The square root of 4 is 2. Done. So the difference with number 3 is this. I can't divide 3 and 100. So what we did in the past was, please ignore the phone, we were supposed to treat them like there were 2 problems. So in other words, try to at least do one of them. Well, can we do the square root of 100? Yep, it comes out even. It's 10. Can you do a factor tree for 3? Can you circle any pairs? Can you do anything to it? And the answer is no. And that's it. So you either divide them if they come out even like this guy, or you treat them separately like that guy. Thanks for watching.